Okay, in this video I want to talk about finding the cross product of two vectors. And the definition of the cross product of two vectors is as follows. So it says if vector A has components A1, A2, A3, B has components B1, B2, B3, then the cross product of those two vectors is defined to be a new vector, and you calculate its components by using the bottom formula. Okay, so there's usually a more standard way to remember it, and I'm going to talk about that. But a couple things real quick. First off, the idea is kind of visually, conceptually, when you're finding the cross product of two vectors, what you're doing is, so you've got one vector A, you've got another vector B. The idea is if you use the right-hand rule, which means we pull vector A into vector B, if we pull that in along the shorter angle, whichever direction your thumb's pointing, that's going to be the direction of the new vector. So if vector A and B were in the plane, then the cross product A cross B would actually be sticking straight up out of the plane. Okay, so this new vector would be perpendicular to both the black vector and the red vector. Okay. So, it's orthogonal to both vectors. The cross product is orthogonal to both of the original vectors. So that's something important to keep in mind. Okay, so a couple computational things. We're going to use determinants basically to calculate the cross product. And remember, the determinant of a 2 by 2 matrix is, so if we have A, B, C, D, we take AD minus BC. And there's a way, if you have a 3 by 3 matrix, to expand it out using this bottom formula. And this is basically going to be the formula we're going to use to calculate the cross product of two vectors. Okay, so maybe I can give myself a little more room here. So let's see. A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, so what we do is, you can show from the definition of a cross product that this is all valid. I'm definitely not going into the theory of it all. But, okay, so what we're going to do is we're going to find the cross product of these two vectors. Okay, so we're going to find the cross product of the vectors. How about 5, 1, 4? That'll be the components of the first vector. That'll be vector A. And then vector B will have components -1, 0, 2. Okay, so remember the first component is what we call the I component, the second is what we call the J component, and then the K component. What we're going to do is we're going to basically replace our A1, A2, A3. What we do is we replace that with the standard basis components, I, J, and K, and then we just write down the components for vector A. So that's got components 5, 1, 4. Vector B has components -1, 0, 2. And then we just use the above formula to calculate the cross product of the two vectors. Okay, so this is going to equal the cross product of, so let me squeeze that in there. This is going to be the cross product of A and B now. Alright, so let's just use our formula here. It says we'll get I, okay, and what we'll have to do, we multiply that by the determinant. We take 1, 4, 0, 2. We put a minus sign in the middle. We take our J, and now we take 5 and 4. And we take -1 and 2. And then we have to add on the K component. And we get the values that go with that by taking 5 and 1 and -1 and 0. And now we just have to compute this this determinant of this little 2 by 2 matrix. So I'm going to put my I out at the end. So again, I guess I should have little lines over those to indicate that they're vectors. So it says we'll get 1 times 2 minus 0 times 4, which is 0. So then we have minus our J component. So we take 5 times 2, which is 10, and then we have to subtract away -4, so that'll turn into +4. and then we have our k component. So it says we take 5 times 0. I guess let me stick him at the end as well. Then we have our k component. So it says we take 5 times 0, which is 0, minus 1 times negative 1, which is going to give us positive 1. And now all we have to do is just simplify that down, and we've got our cross product. Okay, so again, this is going to be a vector that's perpendicular to both a and b. So if we simplify that down, to me it looks like we get 2i, it looks like we get minus 14j, and then it looks like we get plus 1 times vector k. Okay, so there we go. We've got our cross product of our two vectors. One way you can check to make sure that you have calculated this cross product correctly, if you're taking a test, or maybe you've got a second to check things. Remember, we said the cross product. So again, the cross product here is going to be given by 2, negative 14, 1. Remember, we said the cross product is orthogonal to both a and b. And remember, two vectors, u and v, are orthogonal if their dot product equals 0. So one thing you could do is simply take the dot product of the vector a cross b. You could dot that with vector a. You can take a cross b, dot it with vector b, and see that you get out the value 0. If not, something's wrong. So again, obviously, if you don't know what a dot product is, hey, I've got a video on that, so feel free to take a look at it. It looks like to me if we take the dot product of our new vector, our cross product vector, and let's do vector a here first. It looks to me like we'll get 2 times 5, which is 10. We'll get negative 14 times 1, which is negative 14. Then we'll get positive 1 times 4. Okay, hey, that to me looks like we get out 0, which means the cross product is orthogonal to a. And then we can do the same thing. We can take the dot product of the cross product with vector b. So now I'm just multiplying and adding respective components. So it says 2 times negative 1 will be negative 2. It looks like we get negative 14 times 0, so plus 0. And then we'll get a positive 1 times a 2, which again is a 0. So hey, that means our cross product is orthogonal to both vectors. And to me, that's a pretty good indication that I did the computations correct. So, alright, I hope this video makes some sense, a little conceptual sense about finding the cross product. Being able to find a cross product is something very important. You'll do it quite often, so it's definitely something I would say worth remembering. So, alright, as always, feel free to post comments and questions if you have any.